I'd like to begin by saying that this video is going to move at a breakneck pace, and still images are going to appear and disappear very quickly, along with any information that I add. So for anyone who actually wants to learn anything, I encourage you to pause the video at various points to actually read things. Thank you. You see my little friend Johnny here? He's a little slow. He doesn't know much about, well, anything. He's a very strange fella, as a matter of fact.
What is a goggle?
You see, in the tech industry, this is what we like to call a dumbass. I mean, just look at that sweet face. He has some questions, and hopefully I can answer them without breaking his weak, fragile mind. If you're lucky, if you can successfully translate the stupid, you might even learn something too. So Johnny, let's start easy. Let's get to it. What do you know about the internet?
Oh, like that one thing that those business people do to get poor people a low paying job.
Oh dear God, this is gonna be a long day.
Oh, wait, it's when two people really love each other and...
That's enough out of you. Okay. I guess we're gonna have to break this into itty bitty chunks, or break his mind, whichever comes first. Alright. So the internet, the physical internet. Bear with me here.
Okay.
So, everything we do online, the different sites we visit, all the phone calls we make, every questionable part of your search history, it's all part of the internet. Databases are a pivotal piece of this. All the stuff people do is stored in them.
Everything?
Oops, forgot my audience. All the things people do online. Databases, when all connected, form what we know as the internet. Since I know I've probably already lost you, I think it might be time for an analogy. A lot of people refer to the internet as the web, and the sites they visit as web browsers. For an idiot such as yourself, this is an excellent way to think of the internet as a whole. A big spider web. Every device we use is being connected by a couple of other strings on a spider web. A couple is important here. You see, when programming and connecting these devices, it's important to build what we call redundancy.
What's a redundancy for?
Buddy, chill. I'm getting there. Redundancy is a failsafe. Basically, we don't want a situation where if one connection disconnects, the whole thing, turns to shit. So, what programmers do then is connect multiple times to multiple different networks. So if one fails, everything is still fine. We call that redundancy. You follow me? Summarize what I just said, please.
So like the internet has databases, and we don't like when they don't work, so we make them better.
You know what, I'll take it. Okay, so we know what the internet is. That took way too long. Let's try going a little more in depth. Just not too much. Let's talk about IP. IP addresses operate similar to regular addresses, except digital. Every device has an IP address, and it tells you where the program is and how to send data to you. This means data can easily find you, which, granted, can be a bad thing sometimes.
Why is that?
Well, hypothetically, if I were to leak your IP address, all these different sites would try to sell you random things. And you'd end up with 300 useless emails in your inbox every 2 hours. So the moral of the story is, don't check your email. Because I'm going to leak your IP address.
Oh, what?
Anyway, TCP and UDP.
We're not going to talk about what you just said?
The purpose of both of these protocols is to transmit data. It acts like a courier between two devices, transmitting data between them. The difference is efficiency versus reliability. TCP being much more reliable it needs a solid connection between the sender and the person who is receiving it. This extra secure basis for sending makes TCP extremely reliable, and it has a very good system for checking issues. It will automatically resend lost or damaged data to make sure the receiver gets everything they need. UDP, on the contrary, is a lot more efficient and doesn't require a secure connection, making it more convenient and easier to use, but it comes at the cost of how well you can rely on it. Because if anything gets lost in transmission, it won't resend, and it's just kind of screwed. There's no way of recovering it, and you sort of just have to take the L. So if you actually care about the person receiving the information, don't use it. You'll be sad.
That's confusing. Can you explain it again?
I'd rather not. You should have listened the first time.
I did, though.
Don't care.
Well, is there anything else I have to learn?
Yes. So let's just keep going before I lose too many brain cells. All right. 2 to go. Let's start with HTTP. HTTP is widely considered to be the foundation of data communication for modern technology, which means, in stupid, that the first thing we do is figure out what it does. It uses a form of communication between the servers and the browsers. It uses APIs to communicate from machine to machine. One machine sends a request to a server, and then the other server responds. It's simple. I'd ask if you have questions, but I don't care, so we're moving on.
But I do have a question.
Shut up, you dense gnome. Anyway, the last thing we have to cover is DNS. When we go onto the internet, we use domain names, like espn.com or start.https.org, etc. Well, the internet hates those. It thinks they suck. So, they use IP addresses, the ones we talked about earlier. But we people do not like those because we like reading stuff, but not with numbers. The job of DNS is to translate these domain names to IP addresses and vice versa, so that both the computer and the person can understand it. That make sense?
Not really. I mean, I got some of it, I guess.
You know what? That's good enough. We can talk about this more later. Maybe. I don't know. I don't know how much of this I can handle. But right now the answer is definitely none. So, bye!
Wait, I wanted to know.